We're going to approach the second logarithm equation basically the same. We want to identify the parent function, so y equals log base 1/3 of x. That's without any extra modifications or transformations to that graph. Then we're going to find the inverse of this, so we're going to find the exponential, so we replace the x's and y's, so reverse the roles of x and y. Then we solve it for y, which means we solve it for y, which means rewrite it as an exponential. This is the exponent I raised 1/3 to get y, so 1/3 to the x equals y. Now this is the exponential equation. We're going to generate some ordered pairs for it. I'm going to put it in this first table for the expo. We're going to put in -1, 0, and 1. If we put it in a -1, 1/3 of -1 is 3, 1/3 to the 0 is 1, and 1/3 to the first power is 1/3. In order to graph our logarithm equation, the log is the inverse of the exponential, so we reverse the roles of these ordered pairs, so 3, -1, 1, 0, 1/3, 1. So make sure you reverse them back to get your logarithm. And now we're going to make all the necessary adjustments. And our adjustments are going to be on the x's and the y's. So first thing we want to do is we want to see, are there any modifications on the x's? And this -1 is not in those grouping symbols. Like last time it was inside, that meant it was going to affect the x's. This time it's not in there. So this -1 is going to affect the y's, and it's going to move our graph down 1. And this is outside the grouping symbols, and it's multiplied, so it's going to affect the y. So both of these are y transformations. And when you have two transformations being done in the same variable, you just go through your order of operations. You would have to multiply first by 2. So all these numbers get multiplied by 2. So that's going to be -2, 0, and 2. And then you're going to take those numbers, you're going to do one more y transformation. Now you're going to subtract 1. So instead of a -2, we're going to graph a -3, -1, and 1. So 3, -1, and 1. We're going to graph these ordered pairs, 3, -3, 1, -1, 1/3, and 1. So 3, -3 is right in here. 1, -1 is right in here. And 1/3, 1 would be approximately here. So this would be the path of our points. So far, we got to remember that there's always a vertical asymptote for every single log graph. Because there is no horizontal shift, it's not going left or right at all. That horizontal or vertical asymptote is on the x-axis, so that helps us get the rest of the shape of our graph. So that's how I would approach graphing logarithmics. First, find the exponential graph, get those ordered pairs, reverse them, then make all your transformations to your log graph, find your x's and y's, plot the ordered pairs, and then put in your vertical asymptote.